April 1942, Western Desert, Libya. The North African campaign had entered a phase in which information mattered as much as firepower. Vast distances, sparse terrain, and rapidly moving formations meant that the side which understood enemy movements first could seize the initiative. Reconnaissance units were therefore essential, yet they were also among the most exposed. British patrols moved far ahead of main forces, often isolated, lightly armored, and expected to avoid contact whenever possible. Doctrine across Europe held that reconnaissance vehicles were not meant to fight. They were to observe, report, and withdraw. What happened in the Libyan desert in 1942 challenged that assumption and reshaped how the British Army conducted mobile warfare. During one such patrol, a British reconnaissance crew sighted German armored vehicles moving across open sand. Under prevailing doctrine, the expected response was immediate withdrawal. German scout cars, frequently armed with 20mm automatic cannons, could easily outgun most British scout vehicles. Engagement usually meant destruction. Yet on this occasion, the British crew did not flee. They turned toward the enemy and fired. A 2-pounder anti-tank shell struck a German half-track at a distance of roughly 400 yards, igniting it almost instantly. Before the enemy could respond, the British vehicle reversed into cover, repositioned, and engaged again. This encounter illustrated a profound shift. Reconnaissance no longer meant helpless observation, it meant choice. To understand why this moment mattered, it is necessary to examine the problem facing British reconnaissance forces in the early years of the Second World War. Britain entered the conflict with armored cars that reflected interwar thinking. Vehicles such as the Morris, Humber, and Marmon Harrington were designed primarily for scouting and liaison. Their armament was limited to light machine guns or the Boys anti-tank rifle, a weapon that was heavy, difficult to handle, and increasingly ineffective as German armor improved. While these vehicles could theoretically damage lightly protected targets, in practice they lacked the penetration and accuracy to survive real combat at operational distances. The disparity was not merely technical, it was psychological. British reconnaissance crews understood that they were being sent forward in vehicles that could not protect them against enemy fire. German scout cars, particularly those equipped with 20mm cannons, could destroy British vehicles before they were even within effective range. Reconnaissance patrols became exercises in evasion rather than intelligence gathering. Commanders reported increasing difficulty finding volunteers for forward patrols. Morale declined, and with it, the quality of intelligence reaching higher headquarters. The British Army faced a paradox. Reconnaissance was essential to modern warfare, yet the tools provided made effective reconnaissance nearly suicidal. This problem became especially acute in North Africa. The desert magnified both strengths and weaknesses. Open terrain allowed long-range visibility but offered little cover. Encounters between reconnaissance units occurred at significant distances, where firepower and armor protection determined survival. German vehicles could dominate these engagements, forcing British patrols to disengage or be destroyed. As a result, British commanders often lacked timely information about enemy movements, limiting their ability to maneuver effectively. The British response required a departure from accepted military thinking. The question was no longer how to build a better scout car, but how to build a reconnaissance vehicle that could fight when necessary. This challenge appeared contradictory. Reconnaissance vehicles needed speed and mobility, yet effective anti-tank weapons were heavy and produced significant recoil. Conventional wisdom held that a wheeled vehicle could not carry a true anti-tank gun without sacrificing performance or reliability. Tanks accepted reduced speed in exchange for armor and firepower. Scout cars accepted vulnerability in exchange for speed. Combining all three qualities seemed impossible. The solution emerged from an unexpected source. Birmingham Small Arms, better known for manufacturing motorcycles and bicycles, had already produced the Dingo scout car before the war. The Dingo was a compact two-man vehicle intended strictly for observation. Yet its chief designer, Sidney S. Smith, recognized that the underlying concept could be expanded. Instead of designing another lightly armed scout, he proposed creating a wheeled vehicle that could perform reconnaissance while mounting the same main gun used by British tanks. Development began in April 1939 on a vehicle initially referred to as the Light Tank Wheeled. The name reflected its ambition. This was not to be an armored car with symbolic firepower, but a true fighting vehicle that happened to use wheels instead of tracks. The weapon chosen was the Ordnance quick-firing 2-pounder, a 40mm anti-tank gun already in service with British armored units. At the time, it was capable of defeating any German armored car and most early war tanks at typical combat ranges. No other reconnaissance vehicle in the world carried comparable armament. The turret selected for the new vehicle was derived directly from the light tank Mark VII Tetrarch, providing a fully enclosed fighting compartment. Secondary armament consisted of a coaxial machine gun with ample ammunition supply. While the 2-pounder lacked an effective high-explosive shell during much of its service, limiting its usefulness against infantry and fortifications, this limitation was acceptable for a reconnaissance role focused primarily on countering enemy vehicles. Mounting such a weapon on a wheeled chassis required radical engineering solutions. The completed vehicle weighed approximately 7.5 tons, nearly twice the weight of the earlier Dingo. This posed severe challenges for transmission, suspension, and structural integrity. Smith's team addressed these issues through a series of innovations that were advanced for their time. A pre-selector gearbox combined with a fluid flywheel allowed smooth gear changes without interrupting engine power. This prevented stalling even under combat conditions and simplified driving under fire. One of the vehicle's most distinctive features was its equal performance in forward and reverse. With identical gear ratios in both directions, the vehicle could withdraw from combat at full speed without turning around, keeping its gun trained on the enemy at all times. This capability proved invaluable in reconnaissance engagements, where rapid disengagement was often the difference between survival and destruction. Power was transmitted to all 4 wheels through an H-drive system, with individual shafts and hub-mounted reduction gears providing exceptional torque. Independent suspension on each wheel ensured good cross-country mobility, while hydraulic disc brakes offered reliable stopping power. A 95-horsepower engine gave the vehicle a road speed of roughly 50 miles per hour and an operational range of about 200 miles. Against prevailing expectations, engineers had produced a vehicle that combined speed, mobility, and genuine anti-tank firepower. Production began in April 1941, but progress was nearly halted by German air raids on Coventry. Bombing forced the dispersal of manufacturing across multiple locations, with components produced in factories never intended for armored vehicle construction. Despite these disruptions, output continued steadily. By the end of the war, nearly 2,700 vehicles had been built, equipping reconnaissance units across every major British theater of operations. The vehicle's arrival in North Africa marked a turning point. Units that had previously avoided contact now engaged enemy reconnaissance forces aggressively. German half-tracks and armored cars, once dominant, became vulnerable. The psychological balance shifted. British crews reported renewed confidence, knowing they could fight back if necessary. Reconnaissance became an active process rather than a passive one, shaping battlefield awareness rather than merely reacting to enemy movements. By mid-1942, British reconnaissance doctrine was evolving. The presence of a vehicle capable of defeating enemy scouts allowed patrols to screen advancing forces more effectively, deny information to the enemy, and exploit opportunities that had previously gone unobserved. Intelligence improved, coordination improved, and morale followed. The consequences extended beyond individual engagements. Reconnaissance units once again became reliable instruments of operational planning, restoring a function that modern warfare could not afford to lose. The significance of this development lay not only in technical innovation, but in the willingness to challenge accepted doctrine. By equipping reconnaissance forces with real combat capability, the British Army acknowledged that observation and combat were not mutually exclusive. In doing so, it reshaped the role of armored reconnaissance and set the stage for its employment across Europe in the later years of the war. July 1943, Sicily. As Allied forces expanded operations beyond North Africa, the demands placed upon reconnaissance units changed, but the underlying requirement remained constant: to see the enemy before being seen and to survive contact long enough to report or exploit what was found. In the rugged terrain of southern Europe, reconnaissance was no longer conducted across open desert, but through narrow roads, villages, and broken ground shaped by centuries of cultivation and fortification. The British armored car that had proven itself in Libya now faced a new environment that would test whether its conceptual strengths were situational or fundamental. In Italy, reconnaissance operations became slower, more deliberate, and more dangerous. Mountain ranges and river valleys constrained movement, forcing vehicles into predictable routes where ambushes were common. German forces used terrain skillfully, positioning anti-tank guns and infantry in defiles and overlooking roads. In such conditions, lightly armed reconnaissance vehicles would have been fatally exposed. The British armored car's enclosed turret, adequate frontal armor, and powerful main gun allowed crews to probe forward cautiously, engage enemy positions when necessary, and withdraw rapidly if resistance proved too strong. Reconnaissance became an exercise in measured aggression rather than blind avoidance. Units operating in Italy reported that the vehicle's compact size and exceptional reverse performance were especially valuable. Crews could advance to the edge of enemy-held ground, fire on detected positions, and retreat without turning, reducing exposure time. In villages and narrow lanes, this ability often meant the difference between survival and destruction. Although the 2-pounder gun remained limited by its lack of high explosive ammunition, its effectiveness against enemy vehicles and light fortifications ensured that reconnaissance patrols could contest German screening forces rather than being driven off by them. As the campaign moved northward through Naples, the Volturno River, and eventually toward Monte Cassino, reconnaissance units increasingly supported larger operational objectives. They screened flanks, identified crossing points, and tracked German withdrawals. In terrain where infantry bore the main burden of combat, reconnaissance vehicles still played a critical role by preventing surprise and maintaining situational awareness. The armored car's performance in Italy demonstrated that its effectiveness was not confined to open desert warfare. Its design principles translated across environments. June 6, 1944, Normandy. The Allied invasion of Northwest Europe represented the most complex amphibious operation in military history. Reconnaissance units landed with assault forces, often under intense fire, with orders to push inland rapidly and secure key routes and crossings.
The conditions were chaotic. Beaches were congested with vehicles and men. Mines, artillery, and anti-tank weapons inflicted heavy losses. Armored reconnaissance vehicles were particularly vulnerable during the initial hours when maneuver space was limited and enemy defenses remained largely intact. Despite these challenges, reconnaissance units pressed forward. Losses were severe, and many vehicles were destroyed by mines or heavy guns shortly after landing. Yet even under these conditions, the ability of reconnaissance vehicles to fight back mattered. Crews could engage enemy positions that blocked exits from the beaches, suppressing resistance long enough for follow-on forces to move inland. While reconnaissance doctrine still emphasized avoidance of decisive combat, circumstances forced flexibility. The armored car's firepower gave crews options that earlier vehicles would not have provided. Once beyond the beaches, reconnaissance units encountered the distinctive terrain of Normandy's bocage. Dense hedgerows bordered narrow lanes, severely limiting visibility and channeling movement. Traditional reconnaissance methods were difficult to apply. Vehicles could not observe across long distances, and sudden encounters at close range were common. The turreted silhouette of armored cars made them conspicuous targets for enemy infantry equipped with anti-tank weapons. In response, British units adapted. Some reconnaissance units had their turrets removed entirely, creating low-profile command and liaison cars, better suited to the hedgerows. This improvisation reflected a broader truth about the vehicle's design. Its chassis and mechanical systems were robust enough to accept modification without compromising reliability. Even when its primary weapon was removed, the vehicle remained valuable due to its mobility, protection, and communications capabilities. As Allied forces broke out of Normandy and advanced rapidly across France, reconnaissance once again became a matter of speed. The liberation of cities and the pursuit of retreating German forces required units that could move quickly, identify weak points, and seize objectives before the enemy could reorganize. In September 1944, reconnaissance elements entered Brussels ahead of main forces, marking the city's liberation. Such advances were not symbolic alone. They prevented German forces from establishing defensive positions and accelerated the collapse of occupation structures. Operation Martin Garden, launched later that month, placed extraordinary demands on reconnaissance. The plan relied on rapid ground movement to relieve airborne troops holding key bridges deep in enemy territory. Reconnaissance units were tasked with finding viable routes through contested areas, often under fire. In these circumstances, the distinction between reconnaissance and combat blurred almost entirely. Vehicles scouted forward, engaged enemy positions that blocked progress, and maneuvered around defenses to maintain momentum. Although Market Garden ultimately failed to achieve its strategic objectives, reconnaissance units performed their roles with determination and adaptability. Their ability to navigate around German defenses and maintain contact with friendly forces under pressure reflected both training and equipment. While no reconnaissance vehicle could compensate for flawed strategic assumptions, the performance of armored reconnaissance units demonstrated the limits of what could reasonably be expected under adverse conditions. A comparison with contemporary German reconnaissance vehicles highlights why the British approach proved effective. The German SDKFZ-222, widely used earlier in the war, mounted a 20mm automatic cannon. While effective against soft targets and lightly armored vehicles, it struggled against better protected designs. Its open-top turret left crews vulnerable to artillery fragments, grenades, and small arms fire from elevated positions. In contrast, the British armored car's enclosed turret and heavier main gun gave it a clear advantage in direct encounters. Later German designs, such as the 8-wheeled Puma armored car, offered formidable capabilities on paper. Armed with a 50mm gun and protected by thicker armor, it represented the peak of German reconnaissance vehicle development. However, production numbers were extremely limited. Fewer than 100 were built, too few to influence the course of the war significantly. The British vehicle, by contrast, was produced in large numbers and deployed widely, ensuring that its advantages were felt consistently across theaters. American reconnaissance vehicles provide a further contrast. The M8 Greyhound, produced in large quantities, emphasized speed and ease of manufacture. Its 37mm gun offered reasonable firepower, but its thin armor, particularly on the floor, left it highly vulnerable to mines. British crews operating American vehicles often improvised additional protection using sandbags, acknowledging a vulnerability that design choices had created. When given a choice, British units frequently preferred their own armored cars, valuing protection and cross-country performance over sheer speed. In 1944, the introduction of the Littlejohn adapter further extended the vehicle's relevance. This device increased the muzzle velocity of special ammunition by compressing the projectile as it exited the barrel. The result was improved armor penetration, allowing reconnaissance crews to threaten heavier enemy vehicles than before. Although the ammunition was scarce and unsuitable for general-purpose use, the adapter demonstrated the adaptability of the original design. A vehicle conceived before the war could still be upgraded to meet evolving battlefield conditions. By the final months of the war, armored reconnaissance units equipped with these vehicles had served in every major British theater. From the deserts of North Africa to the streets of German cities, they performed tasks that ranged from screening advances to seizing key objectives. In May 1945, British forces entered Hamburg, marking the end of the vehicle's wartime service in Europe. The same units that had first tested it under fire in the desert now brought it into the heart of the defeated Reich. The end of the war did not end the vehicle's usefulness. Many armies retained it in service for years, recognizing that its combination of mobility, protection, and firepower remained relevant. In British service, it was not fully withdrawn until 1960. Attempts to replace it with newer designs revealed an unexpected truth. The older vehicle often outperformed its intended successors in reliability and cross-country mobility. As a result, some replacement programs were curtailed. Former British colonies and Allied nations also employed the vehicle long after 1945. In Asia, it proved effective in counterinsurgency operations, where mobility and protection were essential. In mountainous terrain, its climbing ability and compact size allowed it to operate where heavier vehicles struggled. Its continued service into the late 20th century testified to the soundness of its original engineering and the foresight of its designers. The long-term significance of this armored car lies in what it represented rather than in any single engagement. It embodied a willingness to rethink established doctrine and accept calculated risk in pursuit of greater effectiveness. By equipping reconnaissance units with genuine combat capability, the British Army acknowledged that modern warfare demanded flexibility. Observation and combat were not opposing roles, but complementary ones, especially in fluid operational environments. The consequences extended beyond the Second World War. Post-war reconnaissance vehicle designs around the world reflected similar priorities: mobility combined with meaningful firepower and adequate protection. The idea that reconnaissance forces should be able to fight for information rather than merely avoid contact became increasingly accepted. This shift did not eliminate risk, but it redistributed it more rationally, giving crews the tools needed to survive and succeed. In historical terms, the vehicle's legacy is measured not by the number built or the battles fought, but by the doctrinal change it enabled. It restored confidence to reconnaissance units at a time when morale and effectiveness were dangerously low. It improved the quality of intelligence available to commanders, and it demonstrated that innovation in military design often begins not with grand strategy, but with a clear understanding of the problems faced by those at the front. By challenging the assumption that reconnaissance vehicles must flee rather than fight, British engineers and commanders provided an answer to a problem others had accepted as unsolvable. The result was a reconnaissance platform that served across continents and decades, shaping how armies understood the relationship between mobility, firepower, and information. In the broader history of the Second World War, it stands as an example of how thoughtful engineering and doctrinal flexibility could produce lasting strategic effects.